All right. Welcome back to the channel. Sorry for a couple weeks without any uploads. I've been horrifically under the weather, and the lab's been very busy. So today we're going to do sequence alignments using 3 different methods. So we'll start with the most advanced, expensive one, which is through SnapGene, which is very handy and nice if you can afford it. But the free version of SnapGene doesn't have the sequence alignment feature enabled. So after that, we'll do Benchling, which is free, an online tool. And then after that, we'll go old school and just do BLAST alignment and have a look at what that looks like. And this is going to be very surface level. I'm not going to be covering in depth how any of this works or any other details that you might be wondering about. So if you're looking for that, maybe ask in the comment section and I can maybe someday in the future address those questions. But today it's just going to be how you do it in these 3 softwares, because multiple new students in the lab, trainees in the lab, have had to learn this and ask a lot. So it's very, it's very straightforward, very simple seeming, but I think this will be helpful at least to minority of people. So let's get into it. So let's say, for example, you have this plasmid map that you've made, plasmid blah, and your inserts are banana, potato, DS red. So we got, and this is for CRISPR, so we got 5' and 3' arms for insertion of potato DS red into the banana locus, right? And so then you do sequencing, and so like if you do whole plasmid sequencing, which is the thing now, which is actually just high throughput sequencing on plasmid, then you get a nice auto-annotated map like these do. And if you do, regular Sanger sequencing, then you get sequences that way as well, right? And so either way, you just take those sequences. If you have them open, it makes it easier, but you don't actually have to have them open. You go to Tools in SnapGene, right? You go to Align Multiple Sequences. This will only work for 3 or more. So if you want to do a comparison of just 2 sequences, you have to use this option here. But this option actually is uglier, but it doesn't matter. So let's just align these 2 sequencing results with our template. So let's unclick that. Let's so you can import open sequences, and then everything that's open is here, and you can click or unclick, right? Import, because we want to import all of those. I always like to have my template on top, so this will actually be the order that they're in when we do the alignment. You can click or unclick all these different alignment options. Cluster Omega tends to work the best and be the most reliable, so I generally don't check the other ones, but I like to have them clicked. I've never had this one work well, so I leave it unclicked. But anyway, so you'll see here in a second. So you just push align. So now it's aligning them. So let's see. Let's get it. Okay, come on. There we go. All right. So if you look over here on the right, you have all these different options. So in this case, we're comparing a template to sequencing results, right? So we're not really interested in consensus. That would be like if we're trying to compare, like sequences from different species and look for conservation, right? So we're going to change that to our template. And then I like to change to match. And you can change the color to whatever you want. Pink, gray. Let's go with gray. All right, so yeah, so you can change all these different things here. Yeah, and so it's showing the consensus up here. And you can change different things. But anyway, that's the basics of it, right? So if you wanted to change which sequencing result you were looking at, you would just change it right here. And I mean, they're pretty much exact matches. So this is very cool. So in this software, you can actually expand and show the features that you've annotated on whichever one, right? So yeah, so your sequencing result, doesn't have very many features annotated, right? Because it's auto-annotated, but they're here. So what I like to do is actually drop down the template sequence, my expected result, and then I can compare where any mutations are, right? And yeah, so then you can compare the sequence. Oh, another thing to note is that in this, in SnapGene, okay, it's going to align the sequences exactly as you give them, right? So you see how, okay, if I do that, it's a lot easier to see. Okay, you see how this is all, basically a perfect match, right? Except all of this, right? That is because 0 is not in the same place for the, the sequencing result from the, from the sequencing result is not the same as the 0 location of the sequencing result is not the same as the 0 location in the plasmid of your template, right? Because that's not defined by you, it's defined by the sequencing facility, right? They don't know what 0 should be. And SnapGene doesn't shift the circular plasmids to align them for some reason, right? So because this was 0 on your template, right? That's where, it's going to start. Also, if your sequencing result is reverse, right? So if you get the reverse complement as your sequencing result, this software won't reverse it. So you actually have to make a new file, copy and paste in your whole sequence result, and then do reverse complement of that and use that file as your to do your alignment, which is kind of annoying. Hopefully they'll fix that in the future, but for now, this is still, in my opinion, the cleanest and nicest way of aligning things, aligning sequencing results. So, all right, so I'm going to go ahead and kill this window and get the Benchling interface set up. 1 minute. Okay, so here we are back at the recording. So yeah, so here's how to align using Benchling. So you can import your files into Benchling. You can actually just import your template and actually here, I'll show you. So right, here's your sequence, here's the map. It's pretty similar to SnapGene. Not quite as clean and nice, I don't think, but it's pretty close. This is not terrible. So you go create new alignment. So you could actually just drag and drop all your files here, right? But we've got them there, so let's go ahead and just search for them. And then just click them and they end up down here. Their DNA. Next, yeah, and then you have some options here, pretty straightforward. We're not doing consensus because we want to actually compare to our template, right? And this one actually chooses, shows you what it's choosing as template. Then you have your options down here. You can do auto. I'm just going to click this Cluster Omega. It's slower, and it won't reverse the sequences, but the other ones will. So if you just push auto, so if you have like a sequencing result or multiple sequencing results, Sanger sequencing, just toss them all in there, push auto, and it'll automatically flip them around to make them align, which is actually, nice compared to SnapGene even. And yeah, so let's just push create alignment, and it did warn us that it takes some time, and you'll see it takes kind of a long time actually. So I'm probably gonna skip ahead from here to when this thing changes to done. All right, there we go. Yeah, so you just push open, and then this is what it looks like. In a lot of ways, this is nicer even than SnapGene, in my opinion. So this is definitely a very usable alternative to SnapGene. Yeah, so like it even has like find mismatches, so it'll automatically take you to where they are, individual base mismatches, and you can change the size of the view, your zoom here by scaling that, and you can go along like this. You see the features here. You can remove those. Yeah, you can add reading frames to all of them or none of them, or individual ones, right? You have a lot of different options here. So this is actually a very nice alignment tool. So I'm not sure about the export. So you know what? Why don't we have a look at that? What's that going to look like? Yeah, so you can even just export it. If you want, like I prefer to actually print my sequences out and keep them in a book with handwritten annotations for mutations and whatnot. So this is this one. So let's go do BLAST, which is the least nice to work with, but is always available, right? So, I mean, this one requires that you set up an account, right? But it is free, so you can use this with a free account. BLAST, you don't have to sign in or anything, so let's go have a look at that. All right, so yeah, go to the BLAST website, nucleotide BLAST, and you can align sequences in here fast and easy without an account. I mean, at this point, Benchling is so, such an easy alternative that you can use on any computer. I kind of don't see the point in using BLAST anymore. You can decide what you want to do, but you'll see in a sec. It's not, great. It was great for its time, but, there's new stuff. So let's grab sequences to put in here you can put them as FASTA. So let's put in our template up here in the top. Yeah, this one. Okay. And they just, yeah, copy that way. Paste. Then I think you can put them, you have to click this button, right? It'll look like this when you first come. So click that button. Now you can add your other sequences sequentially. Oh, oops, I need to re-add the template as well. Oops, where is it? There. All right. And there. Now let's grab the template. All right, you can select different things. I'm going to go with high similarity, so like the length of similar sequences that it's gonna break up, it's gonna be longer. I just want this to be faster, and I know that these are basically the same thing, so. Okay, here we go. Yeah, very fast. Alignments. This is what they look like. You know, you scroll down. Now, mismatches are really hard to see in here, right? Like these ones are a little bit easier to see, but if you have like a single point mutation, right? There's one in this line. Do you see it? Takes a while. It's right there. So, I mean, this works, but it's obviously very rudimentary feeling compared to, you know, the other two methods. But this is how we did it for years, a long time ago, so. I believe APE also has an alignment feature, maybe? No, it definitely does. So you could also use that. That's a very old software. I don't like it, so I'm not going to include it here. But you can check that out also. One thing I will say is if you're wanting to look at alignments in BLAST like this, a good thing to do is like slide your chair way back, and then like these gaps become more obvious, you know. You can see them better. So anyway, if you just slide back away from the screen and then, but again, like I said, just use the other ones, I think. But be aware that this is available. And of course, BLAST is still great for searching genomes, right? And mRNA mRNA databases. So, you know, for that sort of thing, it's great. So like if you sequence your plasmid and you have some weird sequence that you don't recognize, throw it into BLAST and see what it is. But anyway, that's it for today. I'm sorry if it was boring. I know it will be actually useful for at least training some of the students here. Save me some time at least. And but yeah, hopefully we'll get some more wet lab video for the next one. Hopefully, we'll see. Any suggestions that you have, please leave them in the comments. I will talk to you next week, hopefully.
You sure about that? You sure about that? You sure about that?
As long as everything's good. Okay. Later.